Okay, today I'm going to talk to you about atom economy. Now, atom economy is a really important thing to consider whenever we're considering a chemical process to make a particular product. So I think it's easiest if I just dive straight in and I show you by using an example. So in this example, we're reacting sodium oxide with hydrochloric acid in order to produce sodium chloride and water. So let's say in this reaction, I'm trying to make sodium chloride. Now, in most chemical reactions, you don't just get one product. You normally get a few different products, or at least a couple of different products. So in this case, sodium chloride is what we're trying to make, but water is our byproduct, is our waste product. So what atom economy kind of shows us is what is the percentage of the mass of reactants which is converted into our desired product. Because the higher the atom economy, the better news for us, and we'll see why that is a little bit later. So, the first thing that we need to do whenever we're dealing with an atom economy equation is, first of all, we need to establish what our desired product is, which is this here. So in this particular experiment, we're trying to make sodium chloride. So we need to figure out what percentage of this overall product is mass is sodium chloride. So what we need to do next is we need to get our periodic table and we need to find out the relative formula mass of this and of our H2O. So first of all, sodium is just here, which is 23. So sodium is, I've got 2 lots of 23, and then I'm going to add it to my chlorine, which is here, so 35.5, but again, there's 2 lots of that, so it's times 2 times 35.5. Now this is going to tell me my the mass, relative formula mass of my sodium chloride. So it's 117. Now, here I've got H2O. So H is just here. So I've got 2 times 1 plus oxygen, which is here, 16. So, I don't need a calculator for that. That's the answer to that is 18. So what I've done is I found the mass of my sodium chloride and the mass of my, relative formula mass of my water. What I now need to do is I need to find the total mass of all of the products. So to do that, it's nice and simple. All I do is 117 plus 18, which gives me a value of 135. So the relative formula mass of all of my products is 135. Now, what I'm interested in to find my atom economy is what percentage of all of these products is my desired product. So my desired product is sodium chloride, and here is the relative formula mass for that, 117. Here is the mass of all of my products. So what I need to do is I need to do 117 out of 135, because this is the proportion of my products which is useful. And to express it as a percentage, all I'm going to do is multiply my answer by 100. So let's quickly do that. 107, oops. It is 117 out of 135 multiplied by 100. So my answer to this is 86.67%. So that's how atom economy works. Obviously, the higher the percentage, the better, because then we've got less wasted products. So let's have a look at one more example. And here's an example right here. Let's imagine we were trying to make magnesium oxide by reacting magnesium with oxygen. Now, just by looking at this, because there's only one product, I can instantly say, see, there's no waste products at all. So therefore, my atom economy in this instance must be 100%. Now, 100% atom economy is really, really good news. And the reason why it's good is there's no waste. No waste at all. So there's 2 really important reasons why it's good not to have waste. First of all, if we have no waste, we have a higher profit. All of our raw materials have been converted into our product, and so we're not wasting any money. It's really economic. Secondly, it's better for the environment. So if we think about environmental issues, we're not producing any harmful waste products. So that's also something to consider when we're considering atom economy. So, just to summarise, or just to recap, atom economy is all about what percentage of our products are, what percentage of the mass of our total products are comprised of our desired product. Thank you very much.